My name's Chris. I'm technical director of a company called TEV Limited. One of our divisions is Master. We make refrigeration equipment in the UK. Okay. So today, we're going to do a summary of the challenges of A2L refrigerants for cold room applications relative to charge limits, flammability limits, room sizes, and pipe runs, and what our A2L system has done to overcome the challenges. Now, one thing I'm going to say is there's a lot of comparisons here against CO2. We also make a lot of CO2 equipment, so we don't dislike CO2. We're just saying that in some cases, the A2Ls can be a lot better in certain situations, depending on your application. And we want to show in our application how they can be much improved. So we're going to go through the F-gas regulation just very briefly, because I know you're probably sick to death of it by now. A little bit on EN378, what our A2L system is, some case studies in terms of the UK, some total cost of ownership comparisons, the environmental benefits, and the software that we have online. So first up, obviously, I'm not going to go through this in too much detail, but we're aware of the phase down, and importantly, the new potential phase down with regards to the anticipated reduction through to 2048, and the fact that actually there'll be a requirement of potentially less than 2.4% of where we were in 2015 in terms of average GWP level. Now I'm going to show you a system that we've got using 454C, which actually brings us down to about 1.3% in terms of the equivalent GWP to a relative system that would have been used in 2015. Okay, so one of the issues with A2L refrigerants is the flammability. So we've looked at the flammability side of it, and it's important to use the minimum amount of refrigerant that you possibly can. It makes it so much easier using A2Ls if you limit the charge size. You can see within the EN378 regulations, there's a limit in terms of 20% of the LFL. So for 454C, that is 293 grams per cubic meter. So for a 20-meter cold room, you're only allowed about 1.2 kilograms of refrigerant. So for a cold room, that's a very low amount of refrigerant, especially if you're trying to do a split system. So what we've done at Master is we've basically changed the design of a refrigeration system and gone for something which is much closer to an air conditioning system. Because it's a condenser, a condensing unit which is cooling only, we can use a microchannel condenser, which obviously reduces the amount of charge that you need. We've removed the receiver out of the system. So there's no receiver, there's no pump down. You run it purely through a connection signal, a cooling run signal from the indoor unit to the outdoor unit. And we fit an electronic expansion valve inside the condensing unit. And this can be set to any of the three refrigerants, whether it be 454A, C, or 455A. What this does is it drastically reduces the amount of refrigerant that you need in an air conditioning system or in a cold room system, being very similar to a refrigeration, well, being similar to an air conditioning system. Reduces the overall GWP relative to what you would have done using like 448 or 449. And we've won various awards. And the other thing that's important to say is that, using the 454C relative to something like CO2, the energy use that you have is much, much less. The skills that are required to use a A2L system are much less, much closer to an existing sort of 448, 449 system. And the actual cost of manufacture and the cost of install is much less. So you get a much lower total cost of ownership. We do systems in the UK, you might be similar, we do cellar systems, which are for cooling beer down. But also we've got systems for cold rooms or for cabinets, and also freezer rooms and freezer cabinets. Okay, so to show an example on here, you can see that we've got an example of one of our systems. This is for a cold room. This will be a 10-meter pipe run, and you can see for a 2.4 kilowatt system on 10 meters, the actual charge size that we'd have on a cold room system would only be 620 grams, which is equivalent to a normal split system. You'd be looking at maybe 3-4 kilograms in terms of refrigerant. That makes it possible to install a system on A2L without any extra measures within EN378, it passes the 2L table in terms of 20% relative to room size. This, using 620 grams, is suitable for room size as small as 10.6 cubic meters, which is basically a small cupboard. So that'd be, far suitable than anything else that you would need. We also do systems for cabinets. What we do is if we get your DM cubed size, we understand what the amount of charge you would need inside your cabinet. And from there, we've got matches on here. We've got a system here, which is a 1.9, needs about 1.9 kilowatts. And it uses an SMC30 system. It's got doors on. And again, for 10 meters, you're looking at about 1 kilogram of refrigerant. Again, it's a very, very low amount, and that's suitable for a shop size of 18 cubic meters. So again, if you've got a really small shop, doing it in this way ensures that you can do it without any additional measures. And this is a cellar cooler system. Anybody who's been to the UK understands that we have draft beer and we cool the beer cellars down. And it's a similar system where for a 2.7 kilowatt system, we only need 480 grams for a 10-meter run. We've got this installed in various places in the UK. One of the areas we've used them is in Central England Co-op. In this particular shop, they had 4 of our systems, 3 chilled systems and 1 freezer system. The overall refrigerant for all 4 systems combined was 3.2 kilograms. So it's a different level in terms of the amount of refrigerant you would normally use. If you're using a standard 448, 449 system, you'd be talking probably 10, 12, 15 kilograms, something like that for the overall store. We're talking 3.2 kilograms of 150 GWP refrigerant. What it means is that the total capital cost is a lot less relative to CO2. The energy consumption is significantly less relative to CO2. So because of the current electricity of where we are right now, the amount of CO2 to produce electricity, it means environmentally at this moment in time, it is actually a better because the GWP requirement on refrigerant is so much lower, but also the energy usage is so much lower. So it actually has a much reduced, or much better impact for the environment, and the total cost of ownership is significantly lower as well. This was another case study that we've done, and this was just a very, very small store. It was a deli in Hereford, and they had 1 cold room system, and their particular system only required 380 grams of refrigerant, which is, again, just a ridiculous amount when you talk about a split system, and very similar relative sort of savings on total cost of ownership and annual savings in terms of environmentalism. We also install, anybody who knows the UK, Asda is a very large supermarket within the UK. We do a lot, we're specified and actually doing our product in Asda cold stores. We've got a very good quote. I'm not going to read it out because of time limit, but we've got various quotes in terms of people who have had our systems and are very happy and they work brilliantly. Here's just a quick example here of against all the different types of refrigerant or different systems that you could have. So if you're using HFCs, you've probably got a typical sort of total cost of ownership to an A2L. The A2L costs more, but they're a bit more efficient in terms of energy. So you get an equivalent total cost of ownership. But we all know that DX systems, in terms of the regulations, are eventually going to be phased out. Against CO2, as we've seen before, we get better total cost of ownership. But against sort of if you have an integral system, problem with integrals is the sort of energy and the regurgitation of heat that you have on those systems. So those are not very good in terms of efficiency. And using secondary glycol, it's, they're okay. But again, you've got the cost of the secondary glycol, which is expensive. But in terms of having a plate heat exchanger, but also the extra inefficiency of a second heat exchange, which also reduces the efficiency. So what it means in terms of annual emissions, you get a much better annual emissions on A2L compared to anything else that is available on the market right now. So we also have software that's available online. If you go to A2Lmaster.com, and on there, we've got this software available for cabinets as well as for cold rooms. And on the cold rooms, you can see on the far, well, that'll be your left. You can see you put in the kilowatt duty, you put in the internal room temperature. So for a cold room, probably 0, 32 degrees ambient, -7, say, for evaporating temperature, 20-meter pipe run, and you put in your room volume and your refrigerant, and it gives you 2 options, whether the size slightly larger and slightly lower. and it tells you what our evaporator is and what our condensing unit is. We offer the complete system. That's important. It makes it much easier for us to understand the exact charge size because it's a critically charged system. We have the suction and the expansion pipe sizes. That tells you the refrigerant charge that you would have in your system and what the minimum room size that would be. And that's available online, free for anybody who wants to go online and have a look and see what system would work for their particular application. And it's important because you can then know prior to any sort of install that you're going to be compliant to EN 378 without any extra requirements in terms of, trying to do something in terms of refrigerant sensors or valves or ATEX fans or anything else you're trying to do to come up with something which is compliant. With this, you're compliant with an EN 378 because the charge is lower than the room size requirement. And here's an example of the systems we've got installed at ASDA. We've also won several awards. We can see here we won the RAC Award in 2020 and the ACR News Awards in 2021 and 2022. Unfortunately, we couldn't put the fact that we've won the 2022 RAC Refrigerant Product of the Year Award because we had to submit this prior to the awards, which were only a couple of weeks ago. But we won the RAC 2022 Product of the Year as well in the UK for this particular product. So thank you. We're based in Hall 6. Stand 117. It's a bit difficult to do questions here, but if you come over to the stand, you can see me or some of the other guys that are on the stand. We've got an A2L system on the stand. We can talk you through. We can show you the components. And also we've got some other equipment on the CO2 side that we can show you as well, which I think you'd find very interesting. All right. Thank you very much.